Hello everyone and welcome in today's tutorial. Today we are going to talk about HC-SR04 ultrasonic module to measure the distance, and we are going to interface this with Arduino Uno. So let's before we get started, we are going to know some basics. HC-SR04 is a low-cost ultrasonic module which is used for distance measurement. So as its name suggests, the ultrasonic module basically it uses an ultrasonic sound waves. It sends 40 kilohertz sound burst into an air, and if the sound burst hits any object, it bounces back. So basically every sound which is above from human hearability, which is the range human can hear, the sound is almost 2 to 20 kilohertz. So above the 20 kilohertz or almost the 22 kilohertz, the human cannot hear the sound. So we use that sound waves for measuring the obstacles because if we use some audible sounds, it will annoy the human ears, and so it will not be a practical use of that sound waves. The phenomena of sound wave is based on their returned policy. So basically similar effect like Doppler and radars are used to when they send a sound wave, and when it hits an object, it return back to the receiver pin. And in this module we have an echo pin from which we measure the duration of the pulse, and that duration determines that how far the object is from that module. So if we need to measure, we use this formula, which is almost the distance will be equal to the duration of the pulse on the echo pin multiplied by 0.034, and you need to divide it with the 2. If you do not understand this formula, just stick with us. We are going to explain this formula very soon. Now this is the look of the module. So the module comes with the two packages. One is this blue color one, and one is the red one. So basically the both are very similar and have 4 pins which two of them you need to interface with the Arduino, and one for VCC and one for ground. So these 2 pins are for positive 5 volts, and the ground is for negative or the reference ground or 0 volts, and the trigger pin is an output pin, and echo pin is then input pin for the microcontroller. I am talking about for input for the microcontroller. So you need to provide, if you are talking with the reference of this module, so you will provide an pulse to the trigger. It will send, when you apply a signal to the trigger pin, it will send the sound wave from the transmitter, and when it does that sound wave, if hit some object, it will bounce back to the receiver, and the duration of that pulse you will get on the echo pin, and you need to read that echo pin in your microcontroller. So first of all, because we are talking about the sound waves, so this is what Wikipedia says about the sound waves, and sound waves travels 343 meters per second. So if you send a burst of the sound waves, it will take 1 second to reach 343 meters. So basically that you will get the idea where that 0.0343 comes from. So basically it comes from this traveling speed of the sound wave in the air, and basically it is measured in a second. So we are not using a second, and neither we are using a meters as our units. So we are using microseconds, and here for the distance we are using centimeters as our units. So we need to convert this into these over desired units. So 343 meters is almost equal to 343,000 centimeters, and 3,400 centimeters, and because 1 meter is equal to 100 centimeter, so that 3,400 centimeters per second. So when you convert this per second into the microsecond, it will become 0.0343 centimeter per microsecond. So if we take an example of this manual calculation, as let's suppose that our object is 5 centimeter away from our ultrasonic module, and that wave, the sound wave, we apply the signal on the trigger pin, and that sound wave start traveling, which is the speed 340 meter per second, and it is almost 343 meter per second basically. So forget this calculation errors, and the 0.0343 centimeter per microsecond, basically that's our reference point, 0.0343 centimeter per second. So it will take 1 microsecond to reach 0.0343 centimeters. So if because our object is 5 centimeters away, so basically to reach that 5 centimeter, the sound wave will take 145.772, almost 140, because this is a floating point calculation, so here you get some trimming errors. The calculation, the floating point calculation errors, the division errors, so it is almost 145.772. It will take that much time, and when it hits then that object, the wave will return back. So it need to reach at the receiver, and it need to travel the same amount of distance, which is a 5 centimeter. So it is almost going to double it, because it is basically going to take about it need to travel about 10 centimeters. So because 5 centimeter to reach till that object, and 5 centimeter to return back. And when it will come back, the receiver, it will take same time, which makes the duration double. So the distance is almost 291.545 when we double this amount. So if we are monitoring this pulse and the echo pin, we will get this duration, and which is 291.545 microsecond pulse, and we need to convert this duration to the distance, and what we'll get, we need to multiply that duration with the speed of the air, which is 0.0343, and because we know this the distance is doubled than the actual distance, we are simply going to divide it by the 2 to get the actual distance, which will be returned as 4.9999 centimeters. So if you round this up, it will automatically become the 5 centimeter, which is our actual distance of the object. So that's enough talk about the understanding how this module work, and let's move on to the coding. So this is our ultrasonic module, and because we need to interface 2 pins for echo and trigger, and what we are going to do is in our script we are going to define these 2 pins. So let's define some values, and let's call it pin for triggering, and let's add this into the pin of number 9, and pin number 10 for echo, and that's 2 pins that we are going to use. And just added some comments. Let's save this, and let's call it HC-SR04 EX01, and we save this. Now what we are going to do is to define that in our for initialize these pins, and one for input and one for as an output. So trigger pin will be treated as an output pin, and the echo pin will be treated as a input pin. So that's all for these two. To read the output, we are going to initialize a serial port so that we can read the distance that measured from this, and let's move on to here. And first of all, let's write a signal to the trigger pin, and let's make it low. Actually, we can do this here, and let's simply move it a little bit for above. And now when we start, we are ready to read that pin. We need to send a signal to that pin, and for that here let's write a signal to trigger pin. And first of all, let's make it high for almost a few microseconds, and you can take a microsecond delay, and let's make it a 10 microsecond, and digital write, and trigger, and make it a low again. So that's all for sending a burst. This signal will send a burst of sound waves, and now we need to read that in. So to read that echo back, we have the function of which is called the pulseIn function, which can measure the length of an input pulse, and you need to provide two arguments to this function. First one is the echo pin, which is an actual pin where this function will read the input signal change. And second thing, either you want to read a high pulse or a low pulse. So in our case, we are going to read a high pulse. This will return a duration of the total pulse length, and let's make it declare this variable somewhere. You can declare in local or a global variable if you are using. Let's make it a local variable. Duration is equal to 0, make it 0 here, and this duration will be updated and here. And now to calculate that distance, you need to make a distance variable here as well, and let's create a distance variable as well, and measure this distance with the same formula that we had seen before, multiplied by 0.0343, and for whole this we need to divide it with the 2, and now we are just sending this distance to the serial port, and for that we are just need to print, and let's take object is, and serial dot print distance, and let's serial dot print centimeter far away, and let's add a line break here. So that's all for reading a distance. Let's add some amount of delay here, and let's measure the next distance after 1 second. So that's all for the code. Now let's move to the hardware, and let's interface. We need 4 pins. So what we are going to do is just taking the 4 wires and just plug these wires like this. So here we added these wires to the ultrasonic module, and now we are going to add these pins to the Arduino. And black wire I had added for the ground and make it ground, and this purple wire is used for the positive 5 volts, and I'm going to add this to positive 5 volts. The next two pins are trigger and echo. Okay, so I had to just shift this like here, and we have trigger close to the VCC, so, and echo close to the ground. Let's see how we declared our pins in the Arduino code, and we had attached a trigger pin with the pin number 9. So let's add the trigger pin which is close to the VCC, this brown, and add it to the pin number 9, and the white wire will be connected to the pin number 10. So that's all the configuration for this. Now connect this Arduino to the computer, and let's add this Arduino, and you can see that Arduino is powered up. Now simply select the COM port and make sure Arduino Uno board is selected from your board, Arduino Uno, and all you have to do is to upload this sketch, and just click on the upload button, or you can go to the sketch and upload, or you can also press Ctrl U. All are same for uploading the code to the Arduino, and just wait for the sketch to compile and then upload into the Arduino microcontroller, which is Atmega 328B. So the AVI dude done flashing the code, and here the TX LED is blinking. It means it is sending that signal in our serial terminal. We can just open up a terminal, and you can see that it is displaying that object is almost 1500 centimeters away. So it is basically, let's try something. Okay, so (22, 23). Here you are also getting a few wrong calculations, as well as you can see where this displays two big or two small numbers. Here you can see the number is getting too big, and let's add a little threshold value here, and into the code. Let's say that if the distance is greater than, let's make reference make a threshold value, and if the distance is greater than how much centimeters you want, let's say 1000. So make it less than this, and only send this information if the distance is less than 1000 centimeters, and in else condition just transmit an serial, or do not transmit anything. Okay, So only send the signal to the serial terminal if the object is closer or less than 100 centimeter. So let's see again. So that's all for the calculation, and we can take some median value. We can read a few of samples, and we can apply some data analysis on that, and we can apply some statistics to make these readings more accurate. We can take average value, we can take most occurrence value, which is the most case, and you can play with the code and see how far your object is to you can make 2 or 3 simultaneous readings, and you can read the most occurrent value in that, and that will be your desired object. And if you want to play with this, let's do this. Now first thing, because our distance is always going to smaller than 1000, we can make it integer, and we can call it current distance. And okay, so we can call this distance a current distance, and let's move this into the function and create a function which will return an integer value and calculate distance, or measure distance will be more meaningful. And move this code into that function. Just skip this, add here, duration could be long, and like this. So what to do, let's make an integer distance is equal to 0, make it long, and here we get. So we turn distance, right? So now we have a ultrasonic calculation function which will measure the distance. All we need to do now is to call this function, and will be this. So let's take a few samples and create an array, and let's take 5 samples, and initially make it all 0, and create a function to fill that sample array, and void take samples. Now create a for loop from 0 to 5, which is our length of the samples. And actually let's take this length from our argument, so that this code will become more portable. And now we can also pass this array in the argument as well, but we are not doing for now. And let's measure distance. Okay, so now let's transmit this array or call it transmit samples, and take the length and transmit these samples to the serial port just like this, and create a for loop here as well from 0 to the length, and let's transmit. Now we want to transmit the dist array, and okay, so we are not sending any prefix when transmitting, but in between we are transmitting a comma, so that's all. Now we need to take samples here and pass a 5. Next, transmit these samples like this, and here take this and this, and after this, so that's the next code. Upload this code into the Arduino and see how it works. Okay, we get too few arguments. We need to provide arguments 5 here as well. Now Control U again, so the code is uploaded. Now view the serial monitor. Cool. So we need to make a little change. I think we okay, we don't need to provide the print line here. Let's re-upload. And boom. So now we are getting this, right? Let's see if we place some object here, what we get. We can fine-tune this code further by adding a little delay here on taking the samples. Here, let's add a little delay of 10 milliseconds taking the next sample, and let's try to take an average value of the distance and take average, or call it average samples, to make it similar in our other sampling code. And let's create a loop here as well, and this loop will be less than the length of the buffer, and what we need a variable is sum val is equal to 0, and this sum val, let's make it long for now. We can optimize it later on, and all we have to do is sum val plus equal to the distance array like this, and here we need to return this value, and we are returning an integer, so let's typecast it to integer, and sum val divided by 5, it will be typecasted into integer and returned here. So let's take this sample here, and instead of transmitting this samples, now let's transmit serial.print average samples, and pass 5 in this function as well. Now upload the code. Okay, so non-lval array. We forgot to add an I pointer here. Let's re-upload. Cool. Now let's see what we got. Okay. One more thing I like to add is that if you want to measure the distance in inches, all you have to do is to add change this constant from 0.01334 and the distance will be in inches like this. So now you are measuring the distance in inches rather than centimeters. So that's all for today's tutorial. Hope you learned, and leave comment if you have some idea to improve this code, and if you have any questions, just leave the comment. So that's all. Thank you.